Okay, weekly contest 367, doing it virtually. Let's go. Okay, lexicographically smallest. Love it. That's going to be an optimization. Indices with index and value difference. 1. Oh, interesting. They make it much harder. Third question. Construct product matrix. I'm curious. Total's 5. That could mean that it's not hard level. Okay. Okay. This requires no optimization. That's easy. Python. Oh man. I need to stop moving before I do contests. Okay. So, I'm going to do nums.each with index, do num I, I'm going to say 0 to I, nope, I want to include it, dot each do j, return ij, if, does it say the order they have to be in? It does not. Where, okay, if I minus j dot abs less than or equal to index difference, and here's the difference of the values, num minus nums j dot abs less than or equal to value difference. Otherwise, -1, -1. Right? Easy peasy. That's not good. Greater than or equal. That makes sense, because otherwise everything would match with itself. You know, I did process that when I read it the first time, and then not when I did this. Okay. 3, 0, 0, 0. This should be fine. Man, if I get a time penalty because I can't read and it says it has to be in the other order, okay, great. So, binary string positive integer k. If there are k1s, shortest beautiful substring. Okay. Got it. That's easy. See, this is why I don't like TypeScript, because I find that annoying and distracting rather than helpful. Okay, so first I want to handle this condition really easily of there are fewer than k1s. So I'm going to do return empty string if s.chars.count char equals 1 less than k. Boom. Okay, I want to make sure that I'm doing that right. It should get, yep, great. So now I want to find the smallest one that's k. Okay. I can't just check every substring, so this is going to be a sliding window. Okay, so left equals 0, right equals 0, cur equals blank. Now those should get grouped together, actually. So until right equals s dot length, count equals 0. Is it easier to start off using the first thing? Let's do it. Ooh, yeah, k has to be at least 1. That's good. Okay. I'm gonna make cur an array just so I can modify it more quickly. Okay. So cur shovel in si. No. I think it's actually easier to start off cur as being s0. Because then I start with my if right away, right? If count is less than k, right plus equals 1, nope, make this blank. I'm going to start right at -1. Cur shovel in s at right, and then I do the check. Count plus equals 1 if s at right equals 1. str's shovel in cur dot join if count equals k. Okay. Else count is not less than k. Could I ever be deleting zeros? I think I want to do this condition regardless. I'm not positive if I need to, but it seems safer. Oh, there we go. Else, I don't even need a left pointer, do I? That's fine. Okay. So else I'm going to say cur.shift count minus equals 1 if s left equals 1, if cur.shift equals 1. No, that is easier. Left plus equals 1. Yeah, that should work. Okay. Strs dot sort, so that'll be lexicographic. Then strs dot sort by str dot length. I want that in reverse though. No, I want the shortest, that's fine. So do str0 dot join. Does that work? str0 dot join. There we go. Oh boy. Oh, I already joined them. Ha! I'm smart. Okay. I believe this works, but let's see if I missed an edge case. Yeah, okay. Right. So this will make sure to always get the shortest ones. I don't think it gets every possibility. It excludes some longer ones, but that's totally fine. This sorts lexigraphically, and then this sorts by length, which takes priority. Yep, great. Okay, I think I already refreshed this one, but just to be safe, so it's Ruby. Okay. Oh boy. So now I have to optimize, yeah. Yep. The index difference I want to do with a sliding window. But that's potentially the whole array, or like half the array, or whatever. Could keep... Can I do something with the insertion sort? No, because I have to remove things too. So I take something out and replace it. Right. And this is 10 to the 9, so I can't do some like counting sort style thing. Okay. Right, because potentially I'm comparing something to the entire array or half the array. If I make the index difference be 10 to the 5 over 2, 50,000. So sort seems impractical. Even something like bubble sort. Like I can keep the index of something, so every time I'm removing something, I'm putting something else and replacing it, so there's no insertion, deletion thing. But bubble sort, bubbling it up, still on average is half of n, which still becomes n squared. Oh boy. Okay, let's do it by value difference. Is that any different? In theory, it shouldn't be, right? So I could sort I could like keep the index, but sort everything by value. And I can check everything within value difference. Again, in principle, though, that shouldn't be any more efficient. Because value difference could cover half the thing, but have none of them match with index difference. Does that work, though? Okay. So... Yeah, I feel it should be symmetrical, but it also feels different to me. So I have conflicting intuitions for this. So I'm going to play out the value difference. So if I do it by value, then I have a sliding window around values, which of course can go up to 10 to the 9, because that's what the values do. Okay, so I could be looking at something like, I could be comparing to most other values, but index difference could be really small. Yeah, so that should be totally symmetrical. Okay. Can I rank them somehow? Would that help at all? So the value window is really big. Okay, well, it might matter because the bounds are different, actually. No, that still wouldn't matter. Ooh, okay. Can I do something like sort them by value plus index? Would that help me at all? That way I'm only comparing... No, because the value could be 0 and the index could be 10 to the 5th or vice versa. Okay, so I can do sliding window with either one, but sliding window with either one doesn't seem to work. Oh my god, it's greater than. Okay, right. Does that matter, though? I think that does matter, actually. Because if it's greater than, then I just care about the max and the min that are out of bounds, right? So... So this is where a heap should work, were it not for the fact that Ruby has terrible heap classes. That's kind of inconvenient. Well, I'm going to try it anyway, and then have it fail, even though it is technically n log n, because Ruby's heaps are terrible. So, index difference has to be at least whatever, right? So, min heap equals min heap.new of nums from index difference to -1, and ditto for max heap. Max heap. And let's just return -1, -1, assuming that it all failed. That's lovely. Okay. So, while let's actually do it this way. Nums.each with index do... Oh, shoot. I actually want the indices of these. Okay, let's do it this way. Nums.map.with index to num_i. Nums.each do num I. Okay. So first I'm going to say if num minus max heap. No, this doesn't work. I can't remove quickly. No, yeah, I can. Otherwise, I can do a priority queue if this doesn't work. If max heap dot peak dot abs greater than or equal to value difference. No, okay, I don't like this. I don't like the heap class a ton. So I'm going to say min q equals this, max q equals this. Okay. I'm totally blanking on how to do this. This is really bad. I feel I use priority queue infrequently enough that I've done it, but I look it up every time. Okay, I'm going to do the heap thing. But I might come back to this. Okay, so first, while min heap dot peak 1 peak 1 minus I, oh boy, dot abs is less than index difference min heap dot pop. And I'm going to do the same logic for max heap. Okay. So if num minus, oh my god, they can be 0, can't they? Well, min heap dot size greater than 0, and okay. If return, and I don't want it, the 0 case bugs me. Return value difference equals 0, 0, 0, negative 1, negative 1, if index difference equals 0. Okay, lovely. Return I and max heap dot peak 1. Okay, and I do the same logic for min. Okay, I also want to add things into this, right? No, but the way I'm doing it, I actually add at the end. Okay, so if I'm starting with index difference already in, I don't want to add that in. It doesn't make a difference, actually. Why not? minheap.add nums at I plus index difference if See, I'm doing a ton of operations here, and the heap class is not super efficient in Ruby. I feel this isn't going to work, even though the logic of it is fine. I also need to add the other way. Heaps.add I minus index difference if I minus index difference is greater than or equal to 0. And ditto for max. Okay. First of all, does this work? Okay. It's not peak, it's peak with an E as opposed to with an A. I swear I've seen it spelled both ways. Dang. No, I don't need peak, I can do max. It's the smarter way to do it. What is it, dot push? So you can tell I almost never use the heap class in Ruby. If num minus, yep, and this should also be max. This should be min. Okay. I'm not super familiar with this class. In theory, this should work, but I'm going to come back to it and do this also medium problem. That probably doesn't require a heap. Okay. 0 index 2D integer matrix array. Product matrix grid. Each element in Pij is the product of all the elements in grid except element grid ij. Lovely. Okay. What's the trick here? Is this going to exceed if I do everything? One grid dot flatten dot each num product times equals num. I don't use inject very much, so I'm not super familiar with the logic. Grid dot each do row dot map val, and here I'm going to do product divided by val mod 1 2 3 4 5. So this is going to work if I did it right. 24 12 8 6 2 0 0. Yeah. Is this going to time out, or is it going to overflow rather? It probably wouldn't time out. It times out? Really? Okay, that's fine. That surprises me, though. Product equals product times num, mod 1, 2, 3, 4, 5. Okay, so the mod is important. That's what prevents it from ever becoming too big. So now I need to do this with power. So I believe that's going to be pow of, dang it, how do you do power with mod? Ba-dum-bum-bum. One, two, three, four, five. First, will it still time out if I do it this inefficient way? Okay. So prod equals product until prod mod val equals 0. Prod plus equals 1, 2, 3, 4, 5. There's got to be a more efficient way to do that. So then this is just going to be prod over val. That's interesting. Should those really all be 0? No, I just want one of those numbers. I want to see if this... No, that can't possibly be... This seems wrong. That seems like the wrong answer. So if I do this, am I going to get the wrong answer? Oh yeah, that doesn't work. Oh boy. Okay. Well, how can I prevent it from overflowing? Do num product times equals num product mod equals 5 if product greater than 1, 2, 3, 4, 5 squared. Will this work? This prevents the number from getting too big, but shouldn't affect the actual mod logic, right? Runtime error. Oh yeah, I don't have prod. I change it to product. Okay. Okay. Well, in that case, This is weird. Okay. Let's do it this way. Let's say mn equals grid.length, grid0.length. Grid equals grid.flatten. Okay. So basically what I'm going to do is I'm going to flatten it. I'm going to do a version of the just divide by a number where you can't use the division thing, because that way I can just keep modding each thing as I go from each side. Not sure if I'm explaining that clearly, but if you're familiar with the other problem where you find the product of each number except the included number without using the division operator, basically you build up the products from the left up to each number and the products from the right up to each number, and then I can't talk. And then you just multiply by the left products up to I and the right products up to I, which includes everything except I. So this will also work in this case, because even though mod has division issues that I don't properly know how to solve, this prevents me from dividing, and I can build up each of the products taking mod each time, which will prevent me from exceeding anything. Now this is a 2D grid. It'd be easier to do with a 1D grid, so I'm just making it 1D, doing this, and then I'm going to rebuild the 2D grid, which is easy peasy. Okay, so left equals 1, right equals 1. I'm going to do these separately. They're similar, but not quite the same. So now I do grid dot each num left shovel in left -1 times num, and this is going to be, of course, mod 1, 2, 3, 4, 5. Okay. Now right is a little different because I do grid dot reverse dot each num, and I'm going to say right dot unshift right 0 times num mod. Grid dot map dot with index. Okay, I think I'm going to need to shift from right, and I technically don't need to pop from left, but I would. So this is num I, and this is going to be left I times right I. Okay, let's see what that gets me right now. Don't care about flattening. 24, 24, 24. Great. Right, so I think I want to do right dot shift here. And strictly speaking, I should do left dot pop. It just doesn't actually matter. 24, 12. Boom. This one should be all zeros. God, that's annoying. Okay. So I'm going to say res equals this. Cur equals this until grid.empty cur shovel in grid.shift if cur.length equals n, then res shovel in cur cur equals blank, and then I return res. Okay, this should work. Why? Okay, I deserve that. Gotta do mod one more time. Is that the only difference? Yes. One of them is different because I multiplied numbers, didn't take the mod. I'm surprised only one of them is different, though, to be honest. Let's go. Okay. Now here's the difficult one that's bugging me. How much time do I have? And how far behind everyone else am I? Okay. Line 21. Oh, yeah, duh. Okay. Well, not great. Plus I have bugs, so people could still pass me. Oh my gosh. I swear, I have seen this both ways. Zero, 3. And ditto here. And this should be min heap. 0, 3, 0, 0, negative 1. Okay, I think my heap syntax is fine. Really? Index difference is 0. What? Okay, here I'm misunderstanding the problem. Again, it is greater than or equal to. Okay, I didn't use the word airy, so that's fun. Well, this is internal to the class. I don't think I can fix anything internals of the class very easily. Okay, priority queue it is. Okay. Let's just do this with max first. Okay, so I want it to be either far away or bigger. So I'm going to do, so max q will first of all include nums -1, and actually I do still want to map index num I. This is going to be num I. Great. Okay, so max q will first get the lowest num. Okay, so nums dot reverse dot each do num I. So max q dot unshift num I if nums if num is strictly greater than max q 0. Okay, yeah, don't use the heap class. Priority queue should do what I want. Right, it doesn't know how to return, so it's not doing this properly. What? There we go. Okay. Oh yeah, that's definitely too many brackets. Because nums I -1 is already an array. Well, that's beautiful. Okay, does max q work? Yes, it does. Okay. Okay. Min q is going to be exactly the same. That's not good. So max q, it should be either bigger or lower index. Min q, it should be either smaller or a lower index. No, I still want -1, don't I? Oh, yeah. That was the issue. Dude, come on. Okay. I'm going to take in nums, index difference, value difference. So I'm going to do my mapping logic here, and then I'm just going to call the function twice. So let's say main of nums, index difference, value difference, or this of nums dot reverse. I'll just return nil so I have a return. Okay, does this work? Judging. Great. So now I just need the actual logic for seeing if there's a thing, right? So I'm going to do nums.each, do num_i. So, if max q0 and, no, first I need to do while. So while max q0 and max q0 1, while this is too low, minus I dot abs is less than index difference max q dot shift. Same thing for min q. I swear, I feel like I'm repeating my work a ton here. Okay, and now I would say if max q0 and max q0 0 minus num dot abs greater than or equal to value difference, I max q0 1. Okay, and ditto for min q. 03, 0, 0, -1, 0, 1, 0, 3, 0, 0. Okay, I don't know what that one was supposed to. I think it was 0, 1. Okay, this should run an O of n. Let's go. Okay. That's the contest. I should have known better than to try the Ruby heap class. Let's see what my ranking is for now, given that I have like a 30-minute time penalty, and it can only get worse. Yeah. Hey, 634. That would be good if it didn't get worse. Okay. So my actual time, though, was 1:26:28. Even with penalties, I technically finished in time. So 1:26:28. Let's see what the real ranking would be. Yep, I give up. 1:26:28 would put me at dun 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 dun. Come on. 12. 1:26. I'm only off by a factor of 10. Not actually 10. Okay. Let's see. 40 is where I'm starting my binary search for 1:26:28. Wow, that was very close. Wait, wrong direction. Here's what I want. No, so I would be 1,069 or 1,070. Yeah, it's not bad. Okay, so that was Virtual Weekly Contest 367. Clearly, I need to be more comfortable with heaps and priority queues because the heap thing just did not work for me. And I tried it anyway. The priority queue thing, it was reasonably straightforward to implement. I should have done it sooner. That's it. Hope this was interesting and helpful.